Time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hi, hello, good evening. Welcome to Unacademy. Let me introduce myself. My name is Banu Prakash, expert in GATE, ESE and PSU's coaching. I did MTech from NIT Kurukshetra. I have 10 plus years of teaching experience and I train many students throughout our country for different competitive exams like GATE, ESE and PSU's like Gen Code Transco, and I expertise in the subjects of electrical machines and power electronics. PPC 10 is my referral code. So use this code, you will get 10% discount on Plus subscription as well as Iconic subscription. Let us know about what are the benefits of the Plus and Iconic subscription. So by taking Plus subscription, you can get live classes from the top educators of the country. Here we have a many teachers per each subject, so that you can select the teacher as per your choice. And second one is you can get structural schedule, and third one is a unlimited practice questions per subject wise and complete mock test or weekly test. And also we can get test series, that is a mock test and that is a mock test, and also test for week, so that you can analyze your performance week by week. Wherever you are weak, you can improve by using the test results. And another one is a iconic subscription. In case of the iconic subscription, what are the benefits? So by taking iconic subscription, you can get all these four benefits. In addition to this, you will get some extra benefits such as personal coach. Personal coach means it is a one-to-one guidance for your GATE, ESE or any PSU preparation. And the second one is you will get proper study planners, that is how to get a rank in the GATE, and similarly how to crack any competitive exam. And another one, how to get rank in or good rank in the IAS. Okay, this is the study planners, how to study each subject. So we will get all these in case of the study planners. And also you can get one more benefits from the iconic subscription, that is expert guidance. And fourth one is a ESC mains questions and answers. So this is the best subscription for ESC preparation. Okay, please take the subscription as early as possible to get the all benefits of the all educators. So if you want to take the subscription, use my code BPC10 is my referral code. So it is my referral code. Use this code, you will get 10% to discount on Plus subscription as well as iconic subscription. Okay. And what about the price for the Plus and iconic subscription? Plus subscription is available for 12 months, 18 months and 24 months. For 12 months fee is 27,225 rupees. Okay, for 18 months fee is 34,650 rupees. And for 24 months fee is 39,600 rupees. Okay, this is the free structure of the Plus subscription. Similarly, what is the fee structure of iconic subscription? So it is available for 12 months and 24 months. For 12 months fee is 45,225 rupees. For 24 months fee is 66,600 rupees. And how to install Unacademy learning app in your phone? So just do one thing, go to Play Store and search Unacademy learning app, and after that install this app in your phone. After the install of this app, you can access the pre-special classes taken by the top educators. If any code is asking, okay, you can use my code. So this is the referral code to get the 10% discount on Plus and iconic subscription. And also it is a invitation code to access the pre-special classes taken by the any educators. Okay. And this is about Unacademy GATE English channel January month schedule. Communication system from 9 to 10 a.m. Engineering mathematics 10 to 11 a.m. Analog electronics 4 to 5 p.m. and in foundation mathematics course for GATE 22 and 23 batches, it is 5 to 6 p.m. and similarly the foundation course for aptitude for GATE 2022 and 23 students, the at 6:15 p.m. to 7:15 p.m. and another one measurement for Genco, Transco, SSC JE, RRB JE. So that is the timing 7:30 p.m. to 8:30 p.m. And next one, electrical machines per Genco, Transco, SSC JE, RRB JE for any competitive exams from 8:30 p.m. to 9:30 p.m. Okay. In this session, I would like to discuss about construction of the transformers. What are the major parts of the transformer and what are the minor parts of the transformers? Majorly, it has two parts. Okay, one is a transformer core. Okay, or magnetic core of the transformer, and second one is a the transformer windings such as LV winding and HV winding of the transformers. As already discussed, what is the mean by LV winding and what is the mean by HV winding of the transformers here. So LV winding means the winding which has less number of the turns. HV winding means the winding which has more number of the turns of the transformers. So these two are major parts of the transformers. And in addition to these major parts, there are some other minor parts. So one is a conservators. Okay. So it is a conservator, and second one is a silica gel breather. Okay, third one is transformer oil. Okay, fourth one is a insulating material used between the laminations of the transformer core are the stands of the transformers, the transformer windings. And fifth one is a bushings, that is nothing but incoming and outgoing terminals. So these are the minor parts. Okay, so suppose see here, this is a conservator of transformer, and these are LV winding, HV winding terminals. Okay, the length of the bushing is high for HV winding terminal, so length of the bushings is the less the LV winding terminals. Okay, this is the LV winding, HV winding terminals, and this part is a LV winding terminals. Got it my point? Okay, next one. What about this one? Okay, this is the part we have shown here. So this is a silica gel breather. Silica gel breather. Okay, and also these parts. Okay, these are the cooling tubes. Okay, here inside, okay, this part is nothing but transformer main tank. Okay, inside the transformer main tank, so there will be a transformer core and transformer winding. So majorly, what are the major parts of the transformer? One is the transformer core, and second one is a transformer winding. And what are the minor parts of the transformer? The conservators, okay, and silica gel breathers, transformer oil, insulating material, the bushings. Okay, bushing is nothing but incoming and outgoing terminals, or LV winding terminal and HV winding terminal. So these are the major parts and minor parts of the transformer. So let us discuss one by one. So what are the design specifications of the transformer, and also desirable the features of the, what are the desirable features of the desirable properties of the transformer core, and after that what is the suitable material to construct the transformer core. The similarly we will discuss about what are the desirable properties of the transformer winding, suitable material to construct the transformer winding, how to place the winding in the core type transformer, how to place winding in the shell type transformer. And one more question, what is the mean by core type transformer, what is the mean by shell type transformer. So all these parts we will discuss one by one in this session. Okay, first one we will discuss about so transformer core part. Okay, okay, listen. So this is a solid transformer core. Okay, and this part is a laminated transformer core. Okay, why transformer core is laminated? To reduce eddy current losses. It is laminated, transformer core is laminated. Purpose of here to reduce the eddy current losses. Got it? Next one. And this is the complete, the vertical part of the core. Suppose this part we have shown here. Okay, from here this part is a vertical parts of the transformer core. So this vertical part of the transformer core is treated as limb of the transformer, limb, and horizontal parts of the transformer core is known as yoke of the transformer. So what is the mean by yoke? So that is the horizontal parts of the transformer core. Part of transformer core. Okay, and limb is nothing but vertical parts of the transformer core. Technical words. Okay, and suppose sometimes we have a question about length of the transformer core, area of the transformer core, and also volume of the transformer core. How do we get here? Length means the length is this is the length of the transformer core. Okay, it is the side and side 2 and similarly side 3, and this is a complete length. Okay, this part is known as, okay, from ear to, okay, starting from ear. Okay, so this is a starting from ear. So this part is known as the length of the transformer core. Okay, starting from here it comes back to this position. Okay, it is a length. So let us assume length of transformer core, it is denoted by LC. Okay, and what about the area of the transformer core? Okay, this is the net cross sectional area of the transformer core. Okay, this part, it is a area of transformer core, and this one is the length. Okay, area of transformer core, so it is denoted by AC. And sometimes we have a question, volume of the transformer core. Okay, how do we get volume of the transformer core? Length of the transformer core multiplied by area of the transformer core. So there are two types of the areas. Okay, one is a net cross sectional area of the transformer core, and second one is a cross sectional area of the transformer core. So what is the mean by net cross sectional area of the transformer core? The area occupied by, okay, by the magnetic material only. Okay, this area is known as area occupied by the magnetic material only, is known as a net cross sectional area of the transformer core. And one more parameter, so that is a gross cross sectional area of the transformer core. What is the mean by gross cross sectional area of the transformer core? So area occupied by both magnetic material and insulating material. Suppose here this is the one laminations, and this is second. So each laminated part is insulated by some insulating materials. So each part, suppose here there is a part is there. So this is the insulated by the insulating materials. So this insulator material between the lamination, so it is a red oxide paints. The red oxide paint. Okay, it is the insulation between the laminations. Lamination means small parts or strip of the transformer core. So this is the red oxide paint is a mostly used insulating material between the laminations of the laminations. Okay, and next one, if the area occupied by only magnetic material is known as a net cross sectional area of the transformer core. If area occupied by both magnetic material and insulating material is known as a gross cross sectional the area of transformer core. So this is a both magnetic materials, the insulating materials. Okay, this area is known as the net gross cross sectional area of the transformer core. So there is a one more factor in the designing point of view. Designing, these all are the designing parameters. Okay, this is the designing parameters of the transformer's core. Okay, so what are the designing parameters of the transformer core? So one is the length of the transformer core, area of the transformer core. So which area? One is the net cross sectional area of the transformer core and gross cross sectional area of the transformer core, and also volume of the transformer core. So this is the length, and this is the complete part is the length, and after that volume of the transformer core, length and area of the cross section. And what about another factor? So that is the stocking factor. Okay, the stocking factor, it is denoted by KS here. So stocking factor is equal to the ratio of the net cross sectional area of the transformer core to the gross cross sectional area of the transformer core. So okay, this is one of the important question in the competitive exam. So if the transformer core is not laminated, then the value of the stocking factor. So if the core is not laminated, then what will happen? The net cross sectional area equal to gross cross sectional area, so that the stocking factor is equal to 1. So this is the one of the question in competitive exam. So like we have a question like this: if the transformer core, is not laminated, so then value of stocking factor would be. Okay, this is our question. And how do we answer? If core is not laminated, so here if core is not laminated, then what will happen? Here AN is equal to AZ. So therefore, so this is equal to KS will become 1. So if the core is laminated, it is always the less than the 1. Okay. So these are the design parameters of the transformer core. And next one, okay, this is the first one, designing parameters of the transformer core. So what is the mean by length, area, volume of the transformer core and stacking factor. The core is not laminated, then the value of the stacking factor is equal to Ks is equal to 1. So next, another one, let us discuss about the desirable properties of transformer core. So very important. Okay, what are the desirable properties of the transformer core? So first desirable property is the transformer core should have low reluctance. Okay, so first desirable property is a transformer core should have low reluctance. Low reluctance. So why low reluctance is required? And again we have a question, what is the mean by reluctance here? So this reluctance is equal to reluctance. We know that reluctance is a reluctance of transformer core. So that is denoted by capital R. So it is equal to length of the core and divided by permeability of the core into area of the cross section. So this is the reluctance. It depends on the length and permeability and also area of the core. Okay, cross sectional area of the transformer core. As a reluctance is a low, then what will happen in the transformer? Why it is desirable property? As a reluctance is a low, so we know that the flux is equal to, okay, this is the we know. So flux is a phi of t. The time varying nature of the flux is equal to mmf by ratio of mmf by the reluctancy of the transformer core. So now here mmf we can write number of the turns multiplied by magnetizing component of the current divided by reluctancy of the core. So by using this equation, so what we conclude, so at number of turns is a constant. Suppose at the finite at finite magnetizing current of the transformer. So flux is a here flux of phi of t is a inversely proportional to reluctancy of the core. So as a reluctance is a low, okay, this is a reluctance is a low. So what will happen? We can improve the flux capability in the transformer core. Okay, are you getting point? So as reluctance is low, okay, flux capability can be improved in transformer core. So that's why it is a desirable property of the transformer core. Okay, and next desirable property of the transformer core, second one is a second desirable property, it should have high value of the permeability. Okay, high value of permeability here. So if permeability is a low, then what will happen? So why high value of the permeability is required? Suppose one of the characteristics of ideal transformer, that is a permeability of the transformer core is infinity. But practically we cannot get the infinity value of permeability of the transformer core, but it should be high. So if permeability is a high, then what will happen? So what is the requirement? So we know according to the here this is the Biot-Savart's law. So B is equal to, okay, here B is equal to the new H, okay, where H is the magnetizing force, B is the flux density. So therefore flux phi of T divided by area of the cross section, that is the net cross section area of the transformer core. So now this is the permeability of the core, okay, multiplied by, okay, here H is a, the here H is the directly, H is the number of turns, okay, multiplied by the magnetizing current of the transformers, okay, magnetizing current. So this is the H, the magnetizing force H is equal to divided by the length, okay, L here, the length of the core. So from here number of turns magnetizing current divided by length of the core, that is a magnetizing force. So from here we can write, so during operation of the operation, okay, during this is the operation, or just wait minute. So if this is the one, I removed all constants, then what will happen? Phi of T, the directly proportional to area of the core, permeability of the core into the magnetizing component of the current, I know of the T. So here permeability is a high value, then what will happen? So if the permeability is a high, the permeability is a high, the requirement of the magnetizing current is a low to maintain the flux constant, the flux constant in the transformers. Got it point? So if permeability is a high, permeability is high value, then what will happen? The requirement of magnetizing current, requirement of magnetizing current will be low, okay, low, to produce the same amount of the, to produce same amount of the flux in the transformers, the flux in transformers. So for example point, suppose we have a transformer core which has the permeability. So this the one transformer core which has the permeability is the high value. So at this condition, in order to create the flux, the requirement of the magnetizing current is equal to 10 amps. So to create the flux of the 5 milliwebers, okay, per example 5 milliwebers here. Similarly, if the another case 1, if permeability is a low, so this is the low value, the requirement of the magnetizing current is equal to 100 amps of the current. So here in 100 amps of the current to create the same amount of the flux in the transformers, so that is equal to 5 milliwebers. So at this condition, how much amount of the current is wasted here? So in the first case, the magnetizing current requirement is a 10 amps. And in the second case, magnetizing current requirement is equal to 100 amps. So by comparing, we conclude that the 90 amps of the current is, okay, 90 amps of the current, magnetizing current is wasted to create the same amount of the flux in the transformers, okay. So which is undesirable. That's why which one is a desirable here? So this parameter, okay, this parameter is a desirable parameter here. So high value of the permeability, the transformer should have high value of permeability to reduce the requirement of the magnetizing current in order to create the flux in transformers. Okay, is that clear, everyone? So now third desirable property. So first desirable property is the transformer core should have low reluctance. And why? Because as a reluctance is a low, the flux capability in the transformer core can be improved. And second one, it should have high value of the permeability, so that you can reduce the amount of the magnetizing current required from the source. That's why it is treated as the desirable property here. And next one, third one, so it should have transformer core should have low hysteresis losses. Okay, so what is the meaning of hysteresis loss? Means losses is the wastage of the power in the form of heat due to temperature rise in winding part of the in the core part of the transformer. Actually, iron losses are the two types. Okay, iron loss are two types. One is the hysteresis loss. Okay, and second one is a eddy current losses of the transformer. So we will discuss very clear whenever we have a discussion about losses of the transformer, but I will give some introduction. Here hysteresis, in order to calculate the hysteresis loss, what is the formula? Hysteresis losses is equal to some constant, so B maximum power of here X, the F multiplied by volume of the transformer core. Similarly, eddy current losses is equal to, so here Ke, some constant, the B maximum square, F square and T square, where T is the thickness of the laminations of the transformer core. So how do we reduce this hysteresis losses? Okay, here the transformer core should have the low hysteresis losses. So it can be obtained by choosing the material which has low hysteresis coefficient. Okay, so hysteresis losses can be reduced. Okay, this is the hysteresis loss can be reduced. How do we reduce this one? So the reduce by choosing the material, which has low hysteresis coefficient. Low hysteresis coefficient. Got it, my point? So that means here X value, okay, this X is known as hysteresis coefficient. Okay, so here X is equal to the low. Okay, this is the X is nothing but hysteresis coefficient. So this can be possible by using the ferromagnetic material. So example point of view, silicon steel is the best suitable, which has the low hysteresis coefficient. This X value is equal to 1.6 for the silicon, the steel material. So remaining all cast iron, cast steel. So this is the more than the 1.6. Okay. So always here we have to, how do we reduce the hysteresis losses? So hysteresis losses can be reduced by choosing the material which has low hysteresis coefficient. So this is the one of the desirable property of the transformer core. And similarly, one more desirable property of the transformer core, that is the transformer core should have the low eddy current losses. Okay, eddy current losses. So this is another property of the desirable property of the transformer core. As the losses are low, then you can improve the efficiency of the transformer. So that's why here desirable property of the core here, one is the low hysteresis losses and also low eddy current losses. So eddy current losses, what is the formula here? Eddy current losses is equal to some constant Ke. So B maximum square, F square and the T square. So during the designing of the transformer, okay, during the designing or manufacturing of the transformer, so this eddy current loss is directly proportional to the square of the thickness of the laminations. Okay, the square of thickness. What is the mean by eddy current here? The circulating current within the core is known as a eddy current, or circulating current in the transformer winding is a copper loss, I square R losses in the transformer winding. So this is the eddy current is a eddy current losses means, so this one is a I square R loss. Okay, I square R loss in transformer core. Okay, this transformer core. So this current here core, the current flows in the core, and this is the resistance of the core. This is not a reluctance, resistance of the core here. So that what we conclude here, eddy current loss directly proportional to square of the conductivity. Current is directly proportional to the conductivity and inversely proportional to the resistance of the core. So this is the conductivity of the core. So one is a cancelled out, the conductivity. So that eddy current loss directly proportional to the conductivity of the core. Okay, so how do we get low eddy current losses in the transformer? So that is we have a two methods. One is laminating the transformer core. As a lamination of the, as a core is laminated, the conductivity of the core will be reduced as there, and thereby eddy current losses will be reduced. So first one, the core is laminated. So just imagine here there is a this is the solid part of the transformer. So solid part, and this one is a laminated part of the transformer core. Okay, like this we have provided laminations here. So what will happen in case of the solid structure? The current passes entire area of the transformer, but here circulating current goes in this area. So now here area occupied by the current, okay, current is a, the here high is more. Okay, next one, the area occupied by the current is a low as compared to this solid structure. Okay, this is the low. And when area is a low, when area is a more, what about the resistance here? Resistance of the core, the resistance is equal to rho L by A. So when area is a more, therefore resistance here, the low value. Okay, similarly the resistance is also the here I value. When resistance is I, what about the conductivity? So conductivity of the core, okay, this is the conductivity, is inversely proportional. So this is the I value, and here conductivity of the core is a low value. So now we know that eddy current loss directly proportional to the conductivity. So that eddy current loss will be I, and here eddy current losses will be low value here. So that's why here by laminating the core, we can reduce the eddy current losses. Okay, and this is the all the desirable properties of the transformer core. So one is it should have low reluctance, high permeability, the low eddy current losses, and also the low hysteresis losses. Okay, is that clear, everyone? Yes, Kavya, good evening. So these are the desirable properties of transformer core. So now let us discuss about what is the suitable material. Suitable material to construct the transformer core. Okay, so now tell me, anybody guess what is the suitable material to construct the transformer core? Thank you very much. Okay, can you tell me what is the suitable material to construct the transformer core? Silicon, is it only silicon or silicon steel? Silicon steel. Okay, so that is the transformer core is made with. So here transformer core is made with silicon steel material. Silicon steel material. Got it? Okay, it should be laminated. Laminated to reduce eddy current losses. Okay, got it point? So here what about the features of the silicon steel? So silicon steel is a ferromagnetic materials. Got it point? So this is the first one. So we have a questions like what are the features of the silicon steel material? Okay. So here this is the ferromagnetic material. It is ferromagnetic material. Got it my point? And it is a composite magnetic material. Composite means the silicon is the one material and steel is the another material. By combination of these two, okay, this is a composite magnetic material. Magnetic material. Okay, and next one, and it is a the how much amount of the composite means we have a one silicon. Okay, this is the silicon material and another one is a steel material. So by composition of these two material you will get a new form of the material. So that is known as a silicon steel material. So it offers, okay, it offers low reluctance and high permeability. Okay, this is the it offers low reluctance and high permeability, and also it has low hysteresis coefficient, and also we can reduce the eddy current losses. So how much amount of the composition? For example, we have a question, percentage of the silicon in the steel material, percentage of the steel in the silicon steel material, like this. So this third one is the 4 to 5%. Okay, this is a 4 to 5% of the silicon is added to the steel material. Silicon is added to the steel to reduce the eddy current. Reduce eddy current losses. Got it point? So these are the features of the silicon steel materials. Okay, all of you clear point? Yes, lamination. We have two methods to reduce the eddy current losses. So one is the 4 to 5% of the silicon is added to the steel. So ferromagnetic material offers low reluctance and high permeability. So that's why we are using composite magnetic material, how much percentage of the silicon, that is a 4 to 5% of the silicon is added to the steel material. Okay, then what will happens? Okay, your question is, if we had more silicon, then what happened? Very good question. If we add more silicon to the steel material, conductivity of the material increases enormously. As the conductivity increases, eddy current losses will be increased. Okay. If more percentage of the silicon, more percent of silicon is added to steel, okay, then conductivity of the core increases very large amount. So as a conductivity increases, as conductivity of the core increases, then what will happen? Eddy current loss directly proportional to the conductivity of the core. So increased in the conductivity increases the eddy current losses. Is it desirable condition? No. So that's why what we have to do here, we have to add very small amount of the silicon to the steel material to reduce the eddy current losses. Okay. Yes, that is also correct. Brittle in nature. That means it will becomes very hard. Transformer core nature will become brittle, so it is a very hard. It cannot bend while designing the core. That is also one more reason. Okay, next third fourth part here we will discuss about types of the transformer core. Okay, anybody can answer what are the types of the transformer cores? There are two types of the transformer core basically. So one is a square type transformer core. Square type transformer core. And second one is step type transformer core. Okay, the square type transformer core means the limb and yoke are designed as like square structure. Suppose here limb and yoke of the transformer core are designed as in the shape of the square. Okay, got it? And this is the limb and yoke of the transformer core are designed as like in the shape of the square means, for example, so this is a one lamination spot. So here okay, so we know here this is the cross sectional area of the transformer core. So this cross sectional area here, So completely as like a square. Okay, this type of the transformer core is known as the square type transformer cores. Okay, got in point? Cross sectional area of the transformer core. Okay, this is the square. Okay, complete. That is the limb and yoke of the transformer. Suppose here if we take, okay, this is the square. Okay, here cross sectional area of the transformer core is are designed as like a square. So this type of the transformer core is known as a square type transformer cores. Okay, and next one, what about the step type transformer core? The step type transformer core means limb and yoke of the transformer. So we know that what is the meaning of the limb? The vertical parts of the transformer core is known as limb, and whereas the yoke is nothing but horizontal parts of the transformer core is known as the yoke. So where limb and yoke of the transformer core are designed as in the shape of stepped manner. Okay, this another name of this one, it is also called cruciform transformer core. Okay, step type transformer core or cruciform transformer core. So exactly what it is seems to be like. So see this figure, all of you. Okay, so here, so this limb is it is not exactly as like a circle, so it is designed as like a steps manner. Okay, suppose this part is a one. Okay, it is a design 1 step, 2 step, 3 step and 4 step. Okay, and similarly 1 step, 2 step. Okay, this is the 4 step. So this is the 4 stepped transformer core. All of it clear? So this type of the core is known as the step type transformer core. All of it clear point? Step type transformer core and also square type transformer core. So here this is the shown like, suppose if I show this limb part. Okay, it is a square. Suppose if we take this part here, so it seems to be like square, right? Cross sectional area. But here cross sectional area is a step type, the stepped manner. So that's why this type of the core is known as a step type transformer core. Is that clear? Types of the transformer core, there are the two types, square type transformer core and step type transformer core. So now we have a question, what are the comparisons between the square type transformer core and step type transformer core? So what are the comparisons between step type transformer core and square type transformer core? So what are the comparisons? Let us take. So one side is the step type, or first one, let us take square type transformer. Okay, and another side is a stepped type transformer. It is also called cruciform transformer core. So this part. So let us take the cross sectional area. Suppose here area of this is the cross sectional area of the transformer core, right? So now here we have taken only one step, okay, like this. The step 1, step 2, okay, like this is a one step transformer core. So here let us assume this the D1 is a diameter, okay, this the complete diameter here, and this is a D2 is a diameter D2 like. So now assume as the D1 is equal to the D2, then what will happen? So diameter of this the two areas is the remain same. The D1 is equal to D2. So what will happen here? The length of the, for example, we have to place the winding on the limb. Suppose this the limb structure is a, this is the one length of the transform, okay, one the limb, okay, one the turn, the second turn, okay, like so on. So like this you can place the winding. Winding is placed on the limb, right? Similarly here, so the same conductor we are placing like, okay, first turn and second turn like so on, okay. So this is the winding which is placed on the limb, okay. And next one, so we have to place the insulation, okay, here in between, here insulation is provided, so to isolate the winding and the core, so this is the insulation requirement. Similarly here also we have to provide the insulation to isolate the winding and the core, otherwise it will be shorted, okay. So now question is, in the which case, okay, the length of the copper requirement per each ton, length of the copper requirement per each ton is more in the square type transformer core. What is the reason? Periphery of the square is a more as compared to, suppose if more number of the steps are provided. So if more number of steps are provided, okay, what will happen? It seems to be like circle, right? Suppose here periphery is a more in case of the square and periphery is a less in case of the ear. So that's why copper requirement is a amount of the copper requirement is a more. Similarly, amount of the insulation requirement is a more in case of the square type, and in case of the step type the amount of the copper requirement is a less, okay, and amount of the insulation requirement is a less as compared to square type. So copper requirement is a more and insulation requirement is also more, so that cost point of view, designing cost here the will be high, right? And here is the designing cost is the low, so as comparison point of view, okay. So these are no actually this is the one limb of the transformer, right? So winding is placed on the limbs like this, okay. I have taken just like a top view. So from the top view, winding is placed on the limb. The here length of the copper wire per each ton on the limb is a high in case of the square type, and length of the here copper wire in case of the step type transformer core per each ton is a small as compared to square type transformer core. What is the reason? Periphery of the square, and compare periphery of the square and periphery of the circle. Okay, and next one, So this is a mechanically balanced well. Mechanically balanced, and but this core is a mechanically unbalanced. Okay, so here even though it has the node point of view, which one is a preferable here? Preferable is a, sometimes we have a questions here like preferable is a square type initially. Square type transformer core is a preferable. Why? Because it is a mechanically balanced well as compared to step type transformer core. So these are the all designing parameters. Okay, first one we have discussed about what are the designing parameters of the transformer core. So that is length, area, volume of the transformer core. Another one, stocking factor. If the transformer core is not laminated, then the value of the stocking factor would be Ks is equal to 1. Okay, and which type of lamination is used between the laminations? Red oxide paints. And why laminations here? To reduce eddy current losses. And we have two types of the areas. One is the net cross-sectional area and gross cross-sectional area. Area occupied by the both magnetic material and insulating material is the gross cross-sectional area of the transformer. And area occupied by the only magnetic material, that is net cross-sectional area of the transformer core. And desirable properties of the transformer core. The transformer core should have low reluctance, high permeability, low hysteresis loss, and also low eddy current losses. And suitable material to construct the transformer core here, silicon steel. What is the reasons here? It is a ferromagnetic material. It offers low reluctance and high permeability. And it is a composite magnetic material. That means 4 to 5% of the silicon is added to the steel material to reduce eddy current losses. And fourth one is it offers low hysteresis coefficient. It offers low hysteresis coefficient. Okay, that means X is equal to 1.6. 1.6 for silicon steel. And types of the transformer core, there are the two types of the core. It is not a core type transformer and shell type transformer. That is the types of the magnetic circuit used in the transformer core. That I will discuss tomorrow. So here types of the cores. One is a square type transformer core and step type transformer core. So limb and yoke of the transformers are designed as in the shape of the square. That means cross-sectional area of the core is the cross-sectional area of the transformer core is square. And next one here, this cross-sectional area of the transformer core is as like in the steps manner. So this type of the core is known as step type transformer core or cruciform transformer cores. Okay, is that clear, everyone? All of it clear? Okay, these are the benefits of the plus and iconic subscription. I repeat once again, see. And by taking plus subscription, you can get live classes from the top educators, and also you can get structural schedule, unlimited practice question and test series. And by taking iconic subscription, you can get personal, all these 4 benefits. In addition to that, personal course, study planners, expert guidance, ESE mains questions and answers. So it is a combat, Unacademy combat, complete crack and conquer. So it is the largest the competition for the gate. It is a competition as the best, super fast, fun and all live leaderboards. So it is the January 12, 2021 at 6 p.m. The register now as early as possible. It is a free of cost. Okay, it is a Evolve Gate 2022 EC batch, which was in English and Hindi, starts on 21st December. So some of the top educators are taking these batches. Please join. And Evolve batch for the Gate 2022 Electrical Batch A, which was in English and Hindi, which was starts on 21st December. Some of top educators are taking these batches. Please join. Okay, and it is official creatrix channel which has 150k plus members. Please join in this group. And it is Unacademy Gate English Telegram group. For any class PDF, please join in this group. Okay, these are the different type of channels under the Unacademy. So one is a Creatrix Gate EEE EC Instrumentation, Unacademy Gate Mechanical, the next one Unacademy Gate Civil, Unacademy Gate English, so Unacademy Computer Science, Unacademy Gate Questions, Electrical Junction. So I'm teaching electrical machine in this channel. All of you please share, like and subscribe this channel. So share this channel to your friends to reach the maximum levels. So thank you all. Thank you very much. Thank you very much. If you have any question, you can ask now. Otherwise, we will wind up the session. Good evening, all. Okay, do you have any question we can ask? Otherwise, we will stop the session. We'll discuss new topic tomorrow. So tomorrow we'll discuss remaining constructional details. That is let us discuss about transformer winding part. So that is in case of the winding, what are the desirable properties? What is the suitable material to construct the transformer winding? And also how do we place the winding in the core type transformer, shell type transformer? Okay, and what are the comparisons between the core type transformer and shell type transformer? This part we will discuss tomorrow. All of you clear now?